And with no further ado, please let me get started. So welcome everyone to this webinar on our study, Breaking Free from Fossil Gas, a New Path to a Climate Neutral Europe. Today we will be focusing on the buildings and district heating sectors. It is one of multiple deep dives we have done. I'll draw your attention to some of those other in a second, and I will be introducing and moderating this webinar. Presentation will be given by our colleagues at TEP Energy, Martin Jakob and Michael Steck, who will be introduced later. And before I start, a couple of words of background on Agora Energiewende and who we are. We are a think tank and policy lab with 4 offices at this point in Berlin, Brussels, Beijing, and Bangkok. We are roughly 100 energy transition experts working really on the substance of how to transition the economies of Germany, Europe, and the world essentially to climate neutrality in the coming decades. We are an independent and nonpartisan think tank with a diverse funding structure, and our vision truly is to create a prosperous and carbon neutral global economy by 2050. We're driven by this mission in our work. And yet we also always advocate and focus on science-based solutions and policy recommendations for delivering this transition. Today we are focusing on, again, this new study by Agora with in collaboration with Artelis, TEP Energy, and Wuppertal Institute, called Breaking Free from Fossil Gas. The background of this study is that we started this project some 18 months ago or so, before also Russia's war of aggression on Ukraine. And at that time, it was really to demonstrate an efficient pathway towards climate neutrality, and a large focus was on the balance between electrons and molecules, a big discussion that was taking place with the invasion or the acceleration of the aggression on the Ukraine. Increased focus was placed on the energy security dimension and the transition away from fossil fuels in Europe in the coming decades. So we went back at the modeling, went deeper, and really tried to stress test how a phase out of fossil gas in Europe could take place by 2050. So this was a core focus of this later modeling effort, and with an intermediate step against the backdrop of the energy crisis and the Ukraine war, of phasing out Russian gas as quickly as possible in our modeling work, defined as by 2027. The focus of the work was on long-lasting demand reductions, so really structural reductions in the demand for fossil gas, as opposed to the short-term behavioral changes or short-term replacement of fossil gas with other fossil fuels, for example. And another focus of the study and the work was on trying to find a cost-optimized balance between direct electrification on the one hand, so the deployment often, for example, in heating of heat pumps and also in industry, electric vehicles in transport, etc. And on the other hand, identifying really the indirect electrification applications that make the most sense, so identifying no regret applications for hydrogen. And we modeled this pathway in 5-year steps, looking at the power, buildings, industry sectors in particular, due to the fact that these are the sectors that are most drawing on fossil gas, and therefore the most essential to be understood for transitioning away from fossil gas in Europe. There was also a modeling in the energy supply that included infrastructure to a limited extent, looking at interconnectors and storage, so the nodes between countries, however, not at the more granular distribution level. And transport and agriculture were indirectly covered in the study for analysis, for example, of overall greenhouse gas emissions, and as an input to our work with regards to demand for electricity and other fuels in transport, for example, but we drew on external studies in this case for transport on work by Transport Environment and for agriculture on work by the European Commission. This system was modeled country by country and bottom up in the sense that the building sector was modeled in detail by TEP Energy, and the industry sector was modeled in detail by Wuppertal Institute, and this fed into an overarching energy system and supply model by Artelis. And so this work is intimately interlinked and gives us this overall picture that we now can show. Another note of background, we worked here in detail with 9 national partners to develop so-called deep dives for these focus countries. The choice of the countries was such that we largely looked at Central and Southeastern European countries against the backdrop of the energy crisis and their particular dependence on Russian gas imports. It also makes for, however, a very interesting stress testing of the pathways that we have developed and show quite a variety of different pathways in the details of this transition that TEP Energy will also be touching upon today. There were 4 key findings of the overarching EU27 study. The first finding was that fossil gas use in Europe can be halved by 2030 and completely phased out by 2050. So we believe we have demonstrated that it is a realistic and plausible outcome of making the right investments and the right policy choices in the coming decades that we can phase out fossil gas in Europe. And we can do this while still maintaining our industrial base in Europe and fully ensuring security of supply, and without relying to a great extent on disruptive behavioral changes to deliver this outcome. The second key finding is that as a result of our modeling, we also have a picture of what this kind of pathway could mean for the development of emissions in Europe. And we find that in our pathway, this scenario could deliver 89% greenhouse gas emissions reductions relative to 1990 levels by 2040, and also a cumulative emission reduction compared to previous modeling by the European Commission, showing that we can go faster and do more than previously anticipated if sufficient political will is to really deliver on ambitious goals. Energy security goals and climate goals. And this is, of course, relevant against the backdrop of the current this work in the European Commission to develop a proposal for a 2040 climate target, something that will be a key point of discussion in the next European Commission. The third key finding is that while, yes, Europe will need a very significant amount of renewable hydrogen to become climate neutral, and especially in the decades after 2030, accelerating also in the period after 2040, the demand by 2030 will be only a fifth of that foreseen in REPowerEU in our scenario. So if we delivered on this scenario, this is, on the other hand, also roughly in line with what the legislators have committed to with regards to renewable hydrogen subtargets in the Fit for 55 package. So our outcomes are roughly aligned with those new political targets, but they are our outcomes are far removed from the very large targets set in REPowerEU, which we believe are very difficult to achieve in such a short term. And we believe it's very important that policymakers focus their attention on realistic and deliverable targets, also for the sake of the industry in Europe being able to bank on realistic amounts of volumes of hydrogen coming to Europe and being deployed in Europe in the coming decades. And finally, we believe that there are some very significant policy consequences from this analysis that must be reflected in ongoing EU legislation. This regards also EU rules on gas hydrogen infrastructure planning, currently being discussed in the gas package, as well as regulations with regards to heating appliances and buildings, which are being negotiated in the eco-design framework of the European Commission, as well as the Energy Performance of Buildings Directive, which is also currently being negotiated. I won't go into further detail on the findings of the study and the overall pathway. Our focus today is on the buildings and district heating sector. I will just simply draw your attention to the fact that we have had multiple webinars so far already diving into each of the other sectors, and as well as a study launch webinar where we go into greater detail on the EU 27 results. I can only encourage you to go to our website and to view those webinar recordings if you want to have further details. And very soon we will also be coming out with a more detailed slide deck with the technical documentation of this scenario. So less of a narrative report as is this study, and more really the details of this pathway, much of which we have already touched upon in these webinars. And with that, I would like to hand over to Martin, Jakob, and Michael Steck from TEP Energy, and I would invite you to please both turn on your webinar, your webcams here. Martin and Michael, I believe you will be sharing this presentation. The floor is yours.
Thank you very much, Andreas, for this comprehensive introduction to this webinar. My name is Martin Jacob. I'm the head of the company TEP Energy. We are based in Zurich, founded as a spin-off company of ETH Zurich back in 2008. And our focus is to analyze demand scenarios and spatial energy analysis, working for energy utilities, municipalities, local governments, national governments, European utilities, energy associations, energy companies, just to give the most important choice of our client spectrum. So energy modeling is a core of our activity, along with doing studies on the ground to understand actually the behavior of building owners, for instance, to gather the cost effectiveness of energy efficiency measures and renewable energy provision in buildings, and more and more in the built environment, so a larger context of the building, not only as one building, but the building as a part of a settlement of a neighborhood, which is very important. And also in terms of timing, the resolution gets more granular with in these last years, where more interest is now given on the monthly and even the hourly sub-level in order to cope with the provision of renewable energy, which is quite different over time, as you know. Today, we will present or deep dive into the building sectors with a focus on the EU 27, sometimes having a glimpse into some differences across the countries, some selective results. If you are interested in more details, then also invite you to read that report that Andreas mentioned, and to ask questions to us in this webinar, for instance. I now would share my my screen, my presentation, to show the presentation, so that you can hopefully see. Can you? Okay, thank you, Michael, for that feedback. Now we just recap those slides of Andreas, and we start right away. So what you can see here is actually a small overview of what we are embedded in a whole energy system. So we are focusing today on this pink box, which is the buildings of both the residential sector and what we call the tertiary sector, which means the buildings, commercial buildings, public buildings of the services sectors, and a part of the green box, which is the energy supply system, and here the district heating part of it. And the other part of the green box was presented in another webinar by Artelis already at an earlier stage. So if we, of course, if we have the building sector, want to break free from fossil energy and avoid future CO2 emissions, then there are some effects where you might have an implication on other sectors, particularly district heating, but also electricity, by the way. So to reduce fossil energy consumption, we can increase energy efficiency. We know that this is not enough to completely break free also because of timing reason, but you always will have a remainder energy consumption. So we need to substitute fossil energy either by heat pumps and or by district heating and or by renewable gases, for instance, biogen origin or synthetically produced. We are focusing in this study on the first two of them, so heat pumps, district heating, and to a certain extent solid biomass, which is missing on that bullet list. Which means if we deploy more heat pumps, more district heating on the demand side, we will have an increase on the supply side of district heating, and in order to have a correct balance in the end, we also will deep dive into that part. Having said, district heating also, of course, means that the current existing district heating also has emissions, which needs to be accounted for, and the current district heating sector also needs to decarbonize, and also we will see that how it goes. So important to note here that we have effects from one sector to the other, and also to the electricity sector, obviously, which is considered in the whole study, but not today. When we first go into the buildings sector, what we are talking about. So we are talking about final energy, which is delivered to first thought, of course, heating, but also hot water, cooking, and also appliances, lighting, cooling, ventilation, pumps, all sorts of different appliances, information and communication technologies, and so on and so forth. So this electricity consumption of this of activities occurring in buildings is part of what we call the final energy, which is delivered by gas utilities, by electricity utilities, by district heating grids, but also on a decentralized form by delivery of fuels. Maybe to note, a bit peculiar is the term of ambient heat. So by that we mean actually energy that is tapped by heat pumps from environmental media such as air, water, geothermal. So in order to have a good distinction between what is the role of energy efficiency, namely to reduce the overall demand, and what is the contribution of such ambient heat, we also balance ambient heat in our results. And obviously, in the case of electricity, we have electricity used from heat application and from the other type of applications, which we also roughly modeled and will be reduced as well, or should be reduced as well in the coming years and decades. As you know, if we need more electricity for heat pumps and electric mobility, there's even more an interest to get more efficient on the appliance size and the building technology side too. How we do that? We have a long-term bottom-up model that is a cooperation between TAP Energy and Fraunhofer ISI, where we model EU27 plus 3 and some more countries, starting with the quantity, the main drivers, which in the case of residential sector is the floor area of residential buildings and the number of households. Number of employee in the case of non-residential buildings as an additional driver that actually would call for the demand of floor area. If you have this, let's say, drivers, then you need to cover this the energy demand of these buildings, which is influenced by, of course, insulation levels, efficiency of building technology and appliances, and very much so indirectly by the lifetime of these components, because this would determine how quickly you can improve energy efficiency, for instance, and how quickly you can displace existing, for instance, heating systems by other ones. If we then from this very or rather abstract level, where we would like to understand, to make a realistic as possible outcome of our studies and analysis and consideration. So we place actually the decision of building owners in the core of our consideration, and the decision of building owners is influenced obviously by the costs of the technologies, by the costs of energy. This in turn is influenced by policy measures, by taxes and fees, for instance. The decision of building owners is also influenced by preferences, by certain willingness to pay, or a certain reluctancy also, possibly against a certain system. So these aspects are very important to consider. This willingness to pay, or the willingness to change, to substitute, can be influenced by policy measures, for instance, by subsidies, by tax incentives that would change the relative economic performance of different systems. You can also, or you need increasingly to work with more stringent policy measures, such as bans, product standards, etc. To a certain extent, also the preferential loans could help to steer the decision of building owners towards more renewable choices, more efficient choices. Sorry. So you can see this more details in the slides that are provided with you. Just here to a very short glimpse on our model, which contains a building database, a cost database, and these databases both feed into the model, the choice model, the discrete choice model we have to reflect the dynamics of the building stock, which is driven by the decisions of the building owners. As I mentioned before, buildings owners' decisions can be influenced, should be influenced to a certain extent by policy measures. What we assumed here in this study is to say, first of all, you should of course avoid any subsidy into fossil fuels. Then on the other hand side, you should actually rather price the CO2 emissions by a carbon tax, for instance, depending which effect very much depends on the level of that tax. For instance, in Switzerland, we are at 120 Swiss franc euros roughly per ton of CO2. So we are somehow already a bit more advanced in that respect. So 100 euro per ton of CO2, just for you to have a notion, is about 2 euro cents per kilowatt hour of gas. So it's a certain contribution, a certain add-on, but also doesn't fundamentally change the relative energy prices, but is a contribution, let's say. Then the buildings need to get more efficient, often only done in the reinvestment cycle, where you can conceive subsidy programs, for instance, but the effect is of such measures is quite long-term, but still needed, as we know, renewable energy potentials are limited in their availability and also in the economics, and so keeping a focus on energy efficiency in buildings is still crucial. We think no fossil energy is needed in new buildings. There are enough technical and also economic solutions to provide new buildings with energy without going into fossil. Fossil heating in existing buildings needs to be avoided as early as possible. Here we have assumed as from the 1st of January 2027. That's most probably feasible. We can still discuss of some exceptions where it's very hard, possibly. And we come to that in relation to district heating system, that you perhaps in some situations need a certain period for planning the switching. Then also in some countries there's also cooking made by fossil gas, and obviously also that needs to be phased out if really complete decarbonization should take place. Having said that, here you see the result of that, all these type of considerations as a aggregate of all 27 EU countries. On the bottom, on the left-hand side of the chart, you see the fossil gas, the coal, the fossil oil. In the middle, you see the electricity consumption of buildings' final energy, including consumption from appliances and building technologies. And on top, you gradually see how ambient heat from tapped from heat pump is actually coming into the solution. Somewhere in the middle, there is a bioenergy that is we see is rather fading out because of different reasons. Actually, we can come to that. And district heating is actually increasing a bit in absolute term and a bit more in relative terms. We have been focusing regarding district heating question on these 9 countries Andreas mentioned. District heating could also play a bit a more prominent role, but needs to be considered very individually to see what is realistic in the different country, mainly because of the question who is actually developing this kind of district heating system. And for this reason, we didn't want to be over optimistic or over stretching actually the role of district heating. Other players see a more prominent role in that, but we were preferring to have a well-founded and only if the analysis was done role of district heating. Having said that, so if we the same chart but without electricity for appliances, you see even more prominently what the role of decentralized heat pump is, and what the role of district heating is, just to have really the focus on the heat sector on this slide. This would all then entail actually a decarbonization of the buildings sector. You can see here the contribution of both the residential building sector and the tertiary building sector, where basically in 2035 emissions are not completely faded out yet, in 2040 almost, and after that we would only see very negligible emissions from the direct emissions from the buildings. So this pathway would then contribute to the overall emissions reduction pathway that was considered in this project, from including the contribution of the other sectors. Now, if we see a bit, how would the different countries cope individually with the challenge of decarbonization? I have picked here two examples where I call it a historical heat pump country, such as Switzerland or Sweden, as opposed to countries that are just starting the heat pump deployment. For instance, the Netherlands, that was very much on gas for a very long time. We picked here Italy on the right-hand side, which started a bit earlier than the Netherlands, but still also has a very high share of gas in the heating sector, and for this reason we starting later, having that a bit also locked-in effect, Italy in the end would have not the same level of heat pump deployment as we see it here for Switzerland, for instance. And so you need to be aware that depending on the starting situation of the different countries, the pathway and the mix and the change of the mix can be vary. So what we see on EU27 can be different from individual countries. Now, how would that actually happen, or how is that possible that we have that decarbonization? So here, just a small example of a comparison of a levelized cost of heat provision of different individual systems in single-family homes, and the message here is basically all of these systems, the cost of all of these systems is about the same. So the differences here is rather often a matter of uncertainty, local condition. Is it easy to change the oil or gas system, or is it complicated? Is it do you have a certain energy provision at all available at the location, and so on and so forth. But the main message of that economic analysis is that we are talking of very small differences across the system. So the lacking economics or cost effectiveness is actually not really a striking argument of not decarbonizing. Often it is discussed whether it's a good idea to switch from, let's say, thermal or fuel-based energies to heat pumps, which are driven mostly or almost mostly exclusively by electricity. So aren't we like exploding the electricity demand? This is an interesting and really an important question, obviously, to answer. The answer is no. There is no risk really that electricity demand is like exploding, as you can see here on the chart. On the one hand side, electricity is dominated in the building sector by other appliances such as lighting, cooling, ventilation, pumps, ICT, etc. This demand is also reduced, or should be reduced, and will be reduced by efficiency improvements over time. Of course, should be supported by policy measures accordingly. And partly this decline is then, or more or less compensated by an increase of electricity demand in space heating, especially heat pumps. At the same time, in some countries, we should also displace direct electric heating systems which are very inefficient. A heat pump could actually replace 3 of those or 4 of those direct electric heating systems. So that kind of potential and efficiency potential was also considered here. Also important or discussed is actually, what does it actually mean in terms of the number of heat pumps delivered? Obviously, the levels of heat pumps that must be provided will increase substantially if we want to have this deployment in energy provision, as I just showed before. At the same time, we need to emphasize that all large heating system producers and suppliers do actually have heat pumps in their portfolio. So it's as opposed to when we started heat pump deployment in Switzerland or Sweden in the 90s, that was very different. You had some small pioneer companies that would almost manufacture heat pumps manually, to say. And currently, of course, we do have an industrial production of heat pumps. Part of the components are imported and then assembled here in Europe. So we do think that the industry can cope with the production of the heat pump system. There might be a certain need of actually educating the installers from their usual skills of installing gas and oil or other type of heating systems to heat pumps, because there is an additional element, which is the electricity part. Often in companies, this installation is shared between specialists of, let's say, the wet part and the electricity part of the system. What does it mean in terms of costs? You always could say, is it the cost or is it an opportunity? Is it an investment? Obviously, we need to increase efficiency investments starting in the building sector, where we still are below of any reasonable retrofit rate. Even if we don't manage to multiply it by 3, we still need to increase, and energy efficiency investment are an opportunity. This is an increasing market, so companies and stakeholders that are invested in such companies is actually good news. They can expand their business, as you can see here on that slide. If we go then for the overall investment pattern, we see especially that a certain peak in period after the 2030s. This is also due a bit to the intermediate goal that was defined in the modeling exercise. The main message here is you need to increase these kind of investments next to the building envelope, which is here let's say the pink, the violet part. There is also investments in renewable energy system, which is the green part, and in between somewhere certain investments in district heating on the building side, and of course on the infrastructure side, which is not part of this chart here. This is what I wanted to convey from the part of the buildings sector. I would now switch to the district heating one. And the first question here is, of course, why is it useful? Why would we need district heating? Is it needed at all? And if yes, why? And from the analysis of the past years, we can actually distinguish two types of motivation, if you like. The first one is a positive one. So it's if district heating is favorable in density and in high energy density areas, settlements, is actually more easy, is more cost effective to provide heat in buildings through district heating systems. So that's a positive motivation. It's also a low-cost solution for building owners. They don't need to invest so much, which is appreciated. And maybe not to neglect, you only need to convince fewer actors to decarbonize the building stock, namely only these district heating companies or those that would expand or create new offers in that area. On the other hand side, there is let's say a motivation negative or a counter, let's say, or how to say in English, if the decentralized system is not easy to implement, then the district heating can step in. So where we have constraints of renewable energy potentials, especially in cities, in the built environment with certain densities, the local potential is very limited, and you need to bring in thermal energy, basically, or fuels into these buildings, and to tap these the energy needed locally can be a real challenge. And in this case, the motivation to bring district heating is not because it's particularly cost efficient or cheap, but it's because simply it's almost one of the only solutions if you don't go for synthetic gas, for instance. There's constraints for decentralized systems. Space is very limited in cities. There's noise to be considered, especially air to water heat pumps. They are noisy. You need to respect some distances depending on the regulation, so often it's not feasible to have an air to water heat pump, and geothermal heat pump might be restricted because of groundwater layers and for some other reasons, or also because the potential is limited. So if you have borehole geothermal heat pumps, you basically can only provide enough energy in single family home neighborhoods, and if you go for higher density, then actually you need to start regenerate the geothermal layers in the summer through waste heat, solar thermal, and so on and so forth. And this is all this is costly in a sense, and in such situations, district heating or grid-bound energy can be very helpful. The disadvantage is here that if also of this decentralized system, you need to convince a lot of actors, namely all the building owners and ideally also the tenants that are living in these kind of buildings and facing the costs. And so from these two perspectives, we see a motivation for district heating as part of the decarbonization process in the built environment. Again, here the countries are starting from very different situation in the topic of district heating provision. You can see here that the share of district heating on final energy demand in buildings, and without going into details, you see there is a tremendous difference between countries that almost have no district heating tradition so far, and other countries where you can reach up to 50%. And if you zoom into larger buildings sector, multifamily homes, non-residential buildings, that share is even higher. You think of countries as and cities such as Stockholm, Copenhagen, Denmark, Sweden, but also Eastern European countries, Poland, Czechia, etc. They do have, at least in certain regions, very high shares of district heating. And between these two countries, which I call the historical ones and the newcomers, the challenges are to a certain extent different. The first one, they rather need to decarbonize their system. They need to pay attention that they can keep the clients, that they don't like switch to decentralized system because of, for instance, the price or also the environmental concerns. In Sweden, owners, they switch back from district heating system because they would like to have a more quick decarbonization. Whereas in other countries, the newcomers, you need to build up first an energy system such as district heating, and this needs time and investment. So how do we consider all this? Not that we were able to formally implement all these steps in the model, but we are considering these kind of aspects, starting actually with the demand side. What is the topology? Do you have single-family house neighborhoods versus other type of neighborhoods? And what is the heat distribution costs in these different type of settlements? And that would determine what is a reasonable scope of district heating coverage in cities and then as a consequence in countries. So this is determined by the heat delivery cost, which is of course also determined by the cost of competing energy systems. So it's an interactive thing at this stage. Once the demand side potential is sort of determined, then the second question is, if the district heating is in place at a certain location for a building or available, well, will that building owner connect or not? And this is modeled in this building stock model type of approach, where we model the decision of building owners as sketched in the beginning of my presentation. On the demand side, supply side, you need to consider which renewable energy sources are available to actually be tapped and to bring renewable heat to the building owners. And these renewable energy sources, they are of very different types and of very different relevance locally. So you can have a lake, you can have a river, you can have a geothermal sources, hydrothermal, geothermal sources, for instance. You can have data centers, you can have industry, you can have a large variety. You can have borehole heat exchanger fields. You can think of solar, thermal solar fields to support, but needs to be considered quite locally. We are working with municipalities, and it's really quite different. And you need to find and balance a reasonable solution each time individually, which is then also a plea for municipal energy planning that could be fostered more in Europe, I think. From that, what is available, complemented by energy that could be transported more easily, for instance, biomass in peak boilers, we determine then the supply mix. The supply mix would then, of course, determine the heat generation costs, and this heat generation costs is also influencing, again, the building stock owner. So that who has the choice between, do I connect or do I choose still to invest myself? So having here just an example, and we did not do that for the whole of Europe for that project, but just to give you a glimpse of an impression, on the right-hand side, for instance, you see how the area that could be delivered by district heating depends on the assumed heat distribution costs. And obviously at the low cost, you can provide center of towns, not necessarily all towns, but highly densely populated settlements in towns. And the more you would increase the heat distribution cost, the more you could expand actually the buildings and the area that could be covered by district heating. We see and on the left hand side, sometimes you can combine actually cold and heat demand or needs of buildings or building owners where you have residential or non-residential buildings. Obviously would have a more pronounced demand for cold, and this would also entail the type of district heating grids. So to go more for an ambient low temperature grid, especially if you can start a district heating grid from scratch, as opposed to historically grown district heating grids which often have a high temperature, which is then the challenge how to bring down that temperature. Just to give you an impression what it actually means, you can maybe focus on the middle column here. So based on an analysis of in Switzerland with cities of more than 10,000 inhabitants, you would see a certain part of the buildings where it's actually very hard to implement decentralized systems. So that's like almost like the natural way to install thermal grid. Then you have quite a large part where actually both is possible. So you can think of thermal grids, but you could also think of heat pumps, particularly geothermal or air. And then there is another part of the building settlements where only one of the two or none of the decentralized system is possible. So depending on how which heat distribution costs are you willing to cope with, you can actually expand obviously the part where the thermal grid could play a solution. If you only accept the low distribution cost, then only 1/3 in this example could be delivered by both, where you have that competition situation, and another 17% where it's almost the exclusive part of district heating. That was on the demand side considerations. And on the supply side, we do see that in each plant or in each system, you will have a mix probably between base load, medium load, and peak load, where base load could be large-scale heat pumps tapping energy from, let's say, water, rivers, or whatever. And peak load could be anything between biomass and even direct electric heating for the last very small part here, and where peak, medium, and base load is very much depends on the local situation. But here our message is not to conceive district heating systems, for instance, that poorly would work on biomass, because first of all, we don't have enough biomass, and secondly, then we lose actually the opportunities of more attractive, more cost-effective baseload sources that are available mostly in many situations. Now, just a few notes which are a bit similar to how to interpret the results as in the building sector. So we also talk about ambient heat. So ambient heat can also be tapped in district heating system by large-scale heat pump. In terms of sources, maybe to pick here the deep geothermal heat that is actually available in different forms. Also, it's the shallow geothermal with small borehole heat exchangers. Then the medium depth one, where you try to get hydrothermal layers. This is done very much in the Paris basin or in Munich, I think so too. And you would have the very deep this geothermal, where you could also produce electricity. We didn't focus so much on the latter one, simply because of you need a time investments, exploration. There's a certain exploration risk whether you find such good layers or not. But this deep, mid-deep geothermal energy is still also a joker in the whole discussion. Again, in terms of what is the mix, in the district heating system, the starting point as well is very different across the countries, as you can see on that chart. So gas, which is the blue one, is dominating in many countries, fossil gas, needless to say. Coal in some of the countries, obviously in Poland, but also in some other ones. Greece, also on a very low level, of course, district heating in Greece. Then biomass was then the choice in countries that started decarbonizing, especially in the Nordics, in the Baltics, and also in Switzerland. They are unfortunately pushing this pure biomass, small district heating grids, and I think, and now they're starting to realize that we don't have enough wood resources to do in such a manner, but we really should use the biomass for the peak, maybe medium load, not for the full coverage of the heat demand. Ambient heat, which is tapped from heat pumps, is still at the very low levels. There are, of course, examples of large-scale heat pumps in Stockholm, for instance, and Vienna, and in other cities. But certainly that needs to play a more prominent role in the future. Now the result from the analysis is, you can see here, is a bit similar in that sense as from the building sector. We need to phase out from fossil gas, which is here, and coal, obviously, which is on the bottom left of the chart. Then we have a bulky contribution of bioenergy, which could even increase a bit in the medium term to quickly phase out fossil energy, but should be, after that, rather be reduced because bioenergy material would, more concretely, should be used in other types of application. Particularly, should be used for construction and putting. So first of all, to displace energy and carbon-intensive traditional construction materials and building types, and secondly also to store at least intermediately carbon in the built environment, in the construction of buildings, instead of just using biomass and wood as an energy source, which very actually basically, when you do so, you at that very moment where wood is burned, you have concrete emissions, although these emissions were captured by nature before, but you will just release it again, as opposed when you use it for construction, then it's at least stored, and there's an opportunity to reuse it several times for quite a long time. So that's the motivation why bioenergy is rather be reduced as well in the district heating sector. We see also a certain contribution of solar energy, as I mentioned earlier, to contribute to the coverage of the heat needed in district heating systems. It entails that you need to have space for implementing such those thermal fields, but in many countries there's enough space for doing so. And on top, you see again here in this pale rose color a certain contribution of ambient heat, which is tapped by large-scale heat pumps, but relatively to the share in the individual buildings, this is at the lower level, but is still there. Here we see the demand of buildings and industry, by the way, whereas on that other chart we see on the one hand side the energy input into district heating system by sources, and here you see a contribution of waste incineration, for instance, direct contribution of electricity, the part of ambient heat separately, and at the same time you see how in the lines how the heat produced is actually going up over the coming years, and at the same time electricity produced from CHPs in district heating systems is rather going down because from an overall systems perspective, the analysis showed that electricity is rather produced by other means than by CHPs in district heating plants, because if you would maintain CHP, then the question would be what is the energy carrier, and so the potentials of biogenic or synthetic fuels is rather limited and more costly, and so the electricity is rather produced by other central means, power plants, or decentral means, obviously wind and solar PV. In terms of emissions, we see here not a complete phase out. The remainder emissions from 2040 are basically those from the incineration of waste, which is in our study balanced as real emissions. Could be, of course, also covered by CCS and captured and stored. So this additional joker we haven't balanced, but if complete decarbonization is needed, of course, then that's one option, and the amount that is needed to be captured is, of course, very limited as compared if you would capture all emissions of today. So that's really 2 orders of magnitude lower what is actually needed to be captured and therefore feasible. Also here, 2 countries that I wanted to select to show that in terms of district heating provision, the countries are at very different starting point. On the left-hand side, you see Poland that has this tradition of district heating, but also not like dominating. There's also other heating sources, especially coal also in small buildings, but still there is a tradition in district heating, as opposed, for instance, to Italy, where it really starts on a very, very low level, and therefore from the interaction with also the national partner in this project, we see a certain contribution of district heating. I personally still see the benefit of district heating in cities, and Italy has some cities in the north that needs to be provided with heat as well. But there's also some barriers. We just come to that actually. And yeah, by the way, concluding, I would like to conclude with these kind of barriers. So the district heating is, my opinion, based on the analysis, part of this decarbonization solution of the built environment, if you like, especially where you have constraints with decentralized systems. And the more you look, the more you analyze, the more you talk with engineers that try to implement decentralized systems in cities, the more you get aware of these challenges, and the more you the benefits, the relative benefits of district heating would then appear. I think it could be an opportunity for energy utilities, especially for those that are in the gas business. To say it very roughly, so to say, providing building owners with gas is like you need to have a pipeline, you need to construct the pipeline, and you need to sell energy. And district heating is almost the same. Of course, not exactly the same, but it's not so far away. So energy utilities could see district heating as a business. But of course, there are some challenges to be considered, and some of them are really crucial challenges. First of all, it needs time and investments. So need to be aware that who is actually providing these investments. I think financials are there. There's extra asset category, which is municipal energy infrastructure investments. But of course, you need to have the player who would then be willing to invest that financial availability. So we need to see at the structural situation and on the interest of players. The utilities, as I mentioned, they could convert their business. So you need to distinguish here, though, by integrated utilities that would have gas, water, district heating, electricity, all in their hands, and so they can better internally manage that transition process, as opposed where you have a situation where with a electricity grid and utility operating in a certain community or municipality, and you will have a regional gas provider, and you will have even a third one for other types of media. And in such a situation, it's the interests might be much more opposing, and so we need to see how we can overcome these structural challenges. Also, not to forget is actually we have a dual and sometimes even triple role of local governments. They are authorities. They should actually advance decarbonization, they should advance municipal energy planning, and so on and so on. And they should make regulation, set targets, etc. But at the same time, they are recipients of tax incomes from energy utilities, and so they are afraid actually to lose kind of the household budget of the community budget if these taxes are breaking away because fossil energy demand is reduced. And of course, sometimes the local government is the owner, and so depending on the constellation, the challenges are quite different. And so having that in mind, policy measures and regulation is needed, I think, to foster the provision of district heating, and only if the interests of the different players are truly considered, then the transition can get a success. That's what I would like to convey at this stage. And I would now, in that sense, give the word back to the moderator, Andreas, I think, to manage Q&As, probably.
Yes, thank you very much, Martin, for this excellent presentation. At least I very much enjoyed it. And maybe you can stop screen sharing. Thank you very much. And we now have an opportunity to take a few questions. And I have a couple already in the Q&A section. Just a reminder to everyone participating. Now's the opportunity to pose those questions. Go into the Q&A function, pose your question. I will draw on them. Depending on how many we have, I will cluster them. Otherwise, I will try to go through them essentially as they come in and really try to address every question. So, first question is a point of clarification. So, The question from the participant is, does the use of process heat from industrial processes for district heating fall under the category of ambient heat? And where did you consider that? So the question was, when considering different types of environmental heat, how was that taken into account?
No, so process heat, some call it waste heat, is not considered as ambient heat. As a matter of fact, we didn't really focus a lot of such what we call the waste heat or process heat. Also because it's because of data situation, and second, but more importantly, ideally process heat should be used more directly within the industry companies, and waste heat should be avoided as much as possible. Of course, there is some waste heat still available. For instance, in data centers, you could either, drive the data center very efficiently and put all the waste to avoid waste heat as much as possible, and put the rest of the waste heat into the air or another media, or you could consider it as a source for a thermal grid. I would say process heat, waste heat is still a joker in the whole discussion, but we didn't systematically reflect it in these figures that I presented.
Yeah, I would just add that in our industry sector modeling, we tried to take into account the waste heat potential for delivering low temperature and medium temperature heat for industrial process heating. So there you will find some details on the waste heat going towards industry heat provision. But indeed, I think it's also an area that requires greater attention. So really identifying what are the potentials and how can this be a viable business option. We recently came out with again for the industry sector, a detailed analysis in German language, and will now also translate into English on power to heat opportunities, and what are also some of the regulatory barriers there. And we just recently launched a study in German on large-scale heat pumps, where we also go into also the at least theoretical potential of waste heat in district heating and industry delivered through large-scale heat pumps. So we see a large potential. In this study, it was not possible to do that for the EU27 level. But indeed, as Martin said, a kind of joker, and yet a lot of things still to be worked out on the regulatory framework, how those incentives can actually be provided. So next question. The question is with regards to the investment data and the focus on buildings components. And the question was, were you able to also calculate the investments needed in district heating and the rollout of heat pumps? So on the one hand, I understand this as the investment for the grids, so to say, the network investment needs for district heating as opposed to the building components, which you highlighted in your slide. And on the other hand, I think in your investment figures, heat pumps was subsumed under renewable energy. So do you have any more detailed figures or cost estimates for the investment needs for heat pumps?
Yes, indeed, as you said, Andreas, heat pumps are part of what we should summarize as a renewable energy system investments. So that could be broken down if that is of interest. The investments into the heat generation of district heating systems were also balanced and provided as a result to the overall analysis. I simply didn't show it today in this presentation.
Thank you. Yeah, so Christian, we can try to follow up with you if you drop us a line. We're happy to also perhaps send you some more some figures on investments in heat pumps. For the last question I have currently, and again, I can encourage the audience to add further questions. What is the reason that biomethane is expected to have a minimal share in decarbonizing buildings and district heating? Is it not available? Is it too expensive? Other question mark.
Yes, I would say it's actually both of the two reasons. So it's the availability is limited. It is quite expensive. So if you add the production of biogas to the distribution of the gas, etc., then often it's not competitive anymore as compared to, for instance, heat pump solution or even district heating. But maybe the other reason is also not within the biomethane, but it's actually where, or not within the building sector, but it actually, are there other better places to use biomethane in the system? And as far as I understand from the other colleagues' results, there are better uses. And so from an overall system point of view, I think the current biomethane levels are maintained or even increased a bit, but maybe Andreas, you can have more insights because you have the overview of the whole study.
Yes, indeed. So to summarize that, from a cost perspective, our analysis did not show, without policy support, one should say, biomethane playing a large role. So then the question was, how do we take into account biomethane in a context where maybe other sectors draw on biomethane cost effectively, but also are there policies that should be reflected as an assumption in the modeling driving biomethane uptake? And we took a more conservative approach on biomethane in full transparency, where we did not choose to force biomethane into the system and essentially kept the biomethane overall in the energy, including biogas, overall in the energy system at today's levels. There are various reasons for that. On the one hand, the cost reasons, but on the other hand, there are considerations around the sustainability of sustainable potential of biomethane, especially in the context where the feedstock for that biomethane is also being drawn on for other uses. So one can think of, for example, sustainable fuels in shipping and aviation. Another difficult to decarbonize sector, but also certain applications in industry, again, as kind of beyond the scope of the building sector. So there was on the one hand a question of sustainability with regards to competition with other sectors, and on the other hand, just the overall availability of the sustainable feedstocks for producing biomethane at large levels. This stands in contrast to current discussions at EU level, driven in large part by the REPowerEU plan, which foresees a 35 BCM biomethane target by 2030, which is a doubling from today's levels in terms of overall biogas and biomethane levels. That doubling is something that we decided not to emulate in this modeling for those conscious reasons. However, I will also, in full transparency, say that there is still room in our understanding to really see where these limits are, and it's something we are further pursuing in our research to better understand where biomethane plays in the overall system. So I would say, for now, just take it as a conservative approach to seeing biomethane's role in the overall energy system, and we'll test that assumption in the coming months and years. We have another question here. I'll read it directly. Could you please clarify the benefits of district heating over decentralized solutions in urban areas? I assume decentral air heat pumps will drop in price significantly due to high market volumes and the coefficient of performance being equal or better compared to bigger heat pumps in district heating grids with comparatively high water temperatures. So how, essentially, I understand this as, how do you see the competition between decentralized heat pumps playing out as district heating develops as a heating solution in urban areas?
Yeah, I think really one of the main, let's say, motivations for district heating is actually to say, okay, decentralized solutions are at these many places very hard really to implement because of so it's not a matter of efficiency necessarily or even costs, but it's more a matter of almost not having other good alternatives, and so not to leave alone these building owners by what should I do now. The district heating could play a beneficial role in such situations. In terms of and as I tried to show on one table, this is not a gray and white matter. So there's a certain part of the built environment where I think it's really hard to have alternatives. Then there's a large part where both of which is thinkable, and so the local authorities, the local utilities should make their homework and assess what is actually meaningful or not. They should also consider the preferences of building owners, which might be towards a connection of a grid because having less own investments, or could also be towards decentralized systems because building owners are individual persons, for instance. So that in that sense is not purely determined by economic analysis or techno-economic one. When it comes to the COP, and by the way, yes, the COP already has improved a lot, but even more importantly, the noise emissions are also dropping because the hip hop industry has recognized that noise is an issue, and actually noise is increasing linearly by the power of the heat pumps. As you know, our auditive system is logarithmic, so 3 decibel more means actually a doubling of the noise, but unfortunately the noise of chillers also on the cold side is increasing exponentially, and so with the power of the system is almost linear. And if you analyze the results from the test center we have here in Switzerland, for instance, you see that gradually new products are coming in, which are less noisy, which is very important because if you have these noises, then you have conflicts with neighbors, you have issues with getting construction permit. It's a very sensitive thing, noise, and so it is worked on these issues by the industry, and still we have made a comparison. If we consider only these less noisy heat pumps, then of course the potential where decentralized heating systems are possible is expanded, but still not. You still have situations where it's not really feasible. And then when it comes to the COP, or annual or seasonal coefficient of performance, yes, if you consider decentralized air water heat pumps with large scale heat pumps in high temperature traditional grids, then it's a challenge for the large scale heat pump. But if you think of expanding or newly creating district heating grids, you should carefully think of what is the right concept, and not necessarily design the supply temperature of such a new grid or an expansion to the worst highest temperature building, but rather to maybe the medium level, and for those buildings that really need, and the first question is, do they really need it? If you make the analysis, to use then a very small additional heat pumps instead of a heat exchanger, and so you can manage actually the temperature, the supply temperature, and that is a very important parameter that should be managed carefully, especially if large-scale heat pumps are used to generate heat.
Thank you. I think that there's a whole set of additional questions one could ask here about what policies need to be put in place to manage this kind of competition that we have now. So, kind of our connection obligations, kind of a policy of the past, something that is needed in certain areas. How does municipal heat planning balance exactly these issues most effectively? But I mean, we can't go into that, unfortunately, today in the same level. I would just try to quickly answer on one follow-up question here we had on the question was, does that mean, so our explanations on biomethane and its role in the system, is it a more limited role compared to hydrogen, or better said, the higher share of hydrogen, something that is largely due to policy support for hydrogen? And one could say, in a simplified way, yes. Whether that's because there is a phase out of fossil fuels by CO2 price or regulation in the long run in industry and buildings, that needs to be filled for higher temperatures. So there is a need to replace it, and there isn't the same cost aggression for hydrogen that we're seeing. We anticipate into the market. And biomethane, we essentially do not see filling that role for economic reasons, and we're not adding policies on top. But I think from just the economics also do not pan out for biomethane in the same way they do for hydrogen over time. So we do anticipate a cost aggression for hydrogen, also just simply due to the scaling of the technology over time, the decline of technologies of the input of wind and solar. So I think there is an economic advantage also to hydrogen next to certain policies that I think push hydrogen more into the market than biomethane. But what I would also add that, yes, simply we do not provide any additional push in terms of policy assumptions driving biomethane into the market beyond its basic effectiveness or suitability in certain industrial applications. So take that answer as you will. But as I said, biomethane is something we would like to further explore its actual potential in that broader context again. So hopefully we'll have more suitable analysis also in the coming years on the exact role of biomethane. For now, we're conservatively skeptical. So with that, I would like to wrap up this webinar. Thank you very much, Martin, and Michael, for your excellent work in this project. It's really been a pleasure over the last 18 months to work together with you.